Hello, welcome to Business Statistics. In this lecture, I will talk about percentiles. So, a percentile is a value where p% of measurements will fall at or below certain value. So, to calculate percentile, these are the steps we need to follow. So the first step would be, for any given data set, we have to arrange the data set in ascending order. So the second step would be to determine the location of the percentile, which is given by L is equal to NP divided by 100. So where L is the location, N is the sample size, P is the percentage or percent. So the next step is, if L is equal to integer, so if we get an integer value, we take the average of L and L plus 1 term. If L is non-integer, it means it's a decimal value, round to greatest. So this is how we calculate percentiles. I will take an example, a data set, and try to calculate different locations. So if we have a data set, so this will be given 8, 10, 12, 4, 7, 6, 19, 22, 14, 12. So the first step is to arrange this data set in an ascending order. So the ascending order would be 4, 6, 7, 8, 10, 12, 12, 14, 19, 22. So the next step would be to determine the location. So if we wanted to determine the 25th percentile, so this will be given. So they will ask you what percentile you want to determine, and that is 25th percentile we want to determine at this time. So we will use our formula, which is L is equal to NP divided by 100. So our P is 25%. So to calculate n is the number of data points, that's a sample size. So our sample size is 3, 6, 9, 10. So our sample size n would be 10. So our location calculation would be 10 multiplied by 25 divided by 100. This comes to 2.5, and this value is a non-integer. Okay, this is non-integer. So we round it off to the greatest value, which is 3. Now we go to our data set and look for third data point. So our third data point would be 7. So that's our 25th percentile. So that is our 25th percentile. So for 25th percentile, we also call it as quartile 1. From now onwards, we will be calling it as quartile 1 or Q1. So our Q1 is 7. So let's calculate 50th percentile. So this is again given. So again we will use the formula L is equal to NP divided by 100. So here our N is 10, P is 50 divided by 100. So this would give us 5. So this is integer. If it is integer, we will take the average of lth and L plus 1th term. So that is, we will take the average of 5th and L plus 1 would be 6. So we will take the average of 5th and 6th term. So our 5th term is 10 and our 6th term is 12. So we will take the average of these two numbers. So that is 10 plus 12 divided by 2, that's 11. So 50th percentile is also called median because it divides the data into two halves. So we studied about 50th percentile previously. So this is our median. Now let's calculate 75th percentile. So again, this is given. So this is our question. We want to calculate 75th percentile. So we do L is equal to NP divided by 100. So that is going to give us, so N is 10, P is 75 divided by 100. So this is 7.5. Again, this is non-integer. So we round it off to the greatest value, which is 8. Again, we can go and look for the 8th location. So this is 8th location would be 3, 6 would be 14. 8. So 75th percentile is called quartile 3. So this is called quartile 3 or Q3. So this is Q3. So to describe any data set, we use something called 5-number summary. So a 5-number summary includes minimum value, quartile 1, median, quartile 3, and maximum value. So a minimum value here in this case is 4. Maybe I will use a different color. Minimum value is 4. Quartile 1 is 7. Median is 11. Quartile 3 is 14. Maximum value is 22. So these 5 numbers describe the entire data set. So let me use a new sheet to explain this concept better. So we had our data set, which is 8, 10, 12, 4, 7, 6, 19, 22, 14, and 12. So we arranged it in ascending order. Which is 4, 6, 7, 8, 10, 12, 12, 14, 19, 22. So this is our minimum value. This is our quartile 1, and then the average of these two, which was median, that's 11, is our median, and then 14 is our quartile 3, and then 22 is our maximum. So what this is saying is, between minimum and quartile 1, 25% of the data will lie. Between quartile 1 and median, 25% of the data will lie. Between median and quartile 3, 25% of the data will lie. Between quartile 3 and maximum, 25% of the data will lie. So it adds up to 100%. So the next concept is interquartile range. So they are asking us what is the range of between the two quarters. So this is given by Q3 minus Q1. So we are trying to calculate the range between quartile 1 and quartile 3, that is 14. So quartile 3 is 14 minus quartile 1 is 7, that is going to give us 7. So interquartile range we also say IQR, so that is 7. The other thing is, what percentage of the data would lie between the two quartiles? Percentage of data that will lie between quartiles. So if you see here, the percentage of the data between quartiles is, this is 25% between quartile 1 to median, and between median to quartile 3 is 25%. So the percent of data that lies between the two quartiles would be 50%. So the next thing which we would be interested in knowing is whether there are outliers. So outliers are extreme values. So outliers can be calculated by the formula Q1 minus 1.5 IQR, and then Q3 plus 1.5 IQR. So this will give us an interval, and all the values in the data set should lie within this interval. If any value is outside this interval, that is an outlier. So let's calculate. Our Q1 is 7 minus 1.5, IQR is 7, and then Q3 is 14 plus 1.5 IQR, which is 7. So this, when you calculate, you will get an interval of negative 3.5 and 24.5. So now we look our data set and see whether all those values within our data set are within this limit. So 8 is within that range, 10 is within that range, 12 is within that range, 4 is within that range, 7 is within that range, 6 is within that range, 19 is within that range, 22, is within that range, 14 is within that range, and 12 is within that range. So this data set have no outliers. Suppose our range was this and we had a data point. Suppose we had 26 in this data set. So clearly 26 is out of negative 3.5 and 24.5. So it's about 24.5. This would have been our outlier. So that's the concept of outlier. Now, based on our 5-number summary, we can draw a box plot. So let me go to a new sheet. So our 5-number summary was we wanted to have a minimum, quartile 1, median, quartile 3, maximum. So our minimum in our problem was 4, quartile 1 was 7, median was 11, and then quartile 3 is 14, maximum was 22. So if we want to plot a box plot, so here is a number line. So our minimum would be 4, and then quartile 1 is 7, median is 11, quartile 3 is 14, and then suppose 22 lies somewhere here. So to plot a box plot at 4, we will put a dot, and then here we will have a line. At median we will have a line, and at quartile 3, so this is minimum Q1, median Q3, and maximum, and then at maximum we will have a dot. So we can join these, and then this line and this line. So that's our box plot. So because this represents our data set, the wider our box plot is, the higher the spread. So here our spread is this much. So if I have another box plot like this, for example, clearly the spread, this spread is less than this spread. So that means this data set has less spread compared to the second data set. And the other thing which we can talk about is this. We can compare the median and we can say this has higher values compared to this data set. So that concludes our lecture on percentiles. Thank you.